So we're going to use the fancy power supplies that you could find in the lab. So I have my 25 volt power supply configured for 5 volts, and those connections are made right here, and that's sitting on the board. So one thing to note is that you could turn the output on or off on these power supplies. Say if I wanted to change some values, I could turn it off, do it safely without worrying about burning any parts out, then turn it back on. So a good indicator, if you have a short circuit, this current will go to 1 amp or it'll get really high. So notice all my circuit elements are taking about 1 milliamp. There's not a lot of stuff going on in here. It's a fairly low power circuit. If you're seeing more than say 10 milliamps, be a little bit concerned. You know, turn it off, check connections, make sure there are no short circuits. So I have that amplifier, the output of the second stage connected to an oscilloscope. So my probe is set on 1x. So I'm using a picoscope, which is back there on the bench. So here's my picoscope waveform. Now I'll pick up the loudspeaker, and thanks touchscreen. Get that out of there. And if I tap the loudspeaker, if I built the circuit right, when I push in, the voltage will go high, like when I push into the speaker. And I want to do that very gently, otherwise I'll break it. So I push into the speaker, the voltage goes high. Okay, so we just showed you a demo of the circuit working. So notice the steady state value is around 2.5 volts, and that was where our rail splitter voltage was, or a reference voltage. So that's the zero, you know, when it goes high and low relative to that signal. And that's what we're talking about by the 2 different phases on the oscilloscope. So I just managed to auto range. So you might want to turn the auto range off and set your scope on ±5 volts for this lab. So now I don't have to worry about the auto range moving around. So now I'm going to do the experiment. I ran the oscilloscope for 1 full sweep, and I captured a few heartbeats. So the heartbeats are these blips over here. So we know 2.5 is our zero, or reference, and so we're getting almost a half of a volt of a blip. So that's my pulse right there at my carotid artery. So if I measure the time delay between those two, and then if I appropriately scale it, I can get my heart rate in beats per minute or frequency or however you want to do it. So that's an interesting thing to measure. Other interesting thing to note is that your heartbeat isn't constant when it's at rest. It's actually variable. So there's a distribution of different time delays in between pulses, and that's a normal thing that people have.